Hi everyone, we are Group 11. This video is about Inch game project of AI planning for autonomy. Next please. The Inch game is an abstractive strategy board game. Our team has considered different approaches to artificial intelligence technologies and adopted the heuristic search algorithm, Monte Carlo tree search, and reinforcement learning. Inch game is summarized as an 11 by 11 two-dimensional array along with some extra words. The difficulty of this project is how to let the agent select the best position on the board game to win against the competitor in the minimum number of steps. To win the game, our agent must have removed 3 of our rings before the competitor based on the board games. Next, please. First of all, we choose A-star algorithm at the beginning of the project since there's already a good implementation in the previous assignment. The core of this technique is to generate a heuristic function in short time. When you use A-star, the space complexity is very limited to find the optimal solution. When constructing the heuristic function, it is important to ensure that the heuristic function is admissible in order to guarantee it is optimal. The time complexity of A-star depends on the heuristic. Next, please. For the strength of A-star, first of all, it is easy to implement. It has a low time complexity as we created a dictionary and stored all the possible sequence in the pickle file. This can save syncing time in initialization by matching the sequence to the corresponding heuristic value in advance. For the weakness of A-star, as A-star heavily relies on the heuristic, it is sensitive to the precise heuristic, and it is also not suitable for competitive game as it only considers itself, cannot consider the potential action for the competitor. Next, please.
And now we are moving on to the MCT. So the primary reason we are using MCT was the success of MCT on AlphaGo. MCT is good for two-player zero-sum turn-based board game, such as Inch, in which the total of all players' profit at the conclusion of the game is equal to 0. The key of MCT is searching. Each node in the MCT tree represents an independent state. If we found a non-expanded node, it will expand and the child node of it will be used for later simulation of the expansion. After simulation, the results are then backpropagated to the tree's node, and the information of nodes along the path is updated. Besides, we use epsilon greedy in an effort to balance MCT choice to explore new nodes and exploit valuable nodes. We also employ the idea of discount rewards to reflect the distance between the nodes and the reward. Next, please. The MCT may stop searching and provide the result at any time. Before to the conclusion, it will repeatedly execute the full process, giving a relatively optimal result for the tree at each instance. By combining the usage of epsilon greedy, MCT has the ability to exploit value nodes, bringing us closer to the victory. However, in our initial experiments, UCT must choose all of the root nodes, child nodes, which is identical to random selection in our case under 1 second limit. In addition, we must record the winning and losing information of each node. And therefore, the challenge is pretty obvious. The number of nodes is pretty large, as will be the number of nodes on each layer. So with the use of epsilon greedy, we also manually set the number of simulation to 10 to save more time for the selection process. Next.
This approach we try is the linear Q-learning algorithm, which differs from normal Q-learning in that it approximates the Q function by linearly combining features and their weights. Instead of recording every detail, we consider what is most necessary to know and model this. In linear Q-learning, it is the features and the weights that are stored, not the state we must therefore know is the weight of each aspect of each action. For the feature sections, in the initial design, we evaluate 5 features. We start with the feature that the next movie in the present state will score. As it directly affects the reward, we construct the second and third features by considering the number of pieces on the board using both sides. Because in the Inch rules, 5 pieces are eliminated once they are in line. Therefore, calculating the ratio of my counters by the opponent counters in the current state can be used to analyze the strengths and weakness of the game. Inspired by Go-bound strategy, the first move frequently lands on this fact. We have built the 4 features, and here this is the game. As you can see, it can go to the each lines based on characters of each game. Among the theories of search algorithm, Monte Carlo tree search and reinforcement learning. From the results, we can conclude that linear Q learning of reinforcement learning is best.